My name is Bryan Holmes. The title of my talk is Investigating the Seattle Fault Through Borehole Analysis in Bellevue, Washington. So first I'm going to go over some of urban geology challenges and opportunities. Modern development obscures features. There's a lack of bedrock exposure. There's complicated stratigraphy in the Puget Lowland. So investigating geology in these landscapes is difficult. But we have opportunities, a variety of geotech data, high-resolution LiDAR data, and subsurface modeling. So these are tools that we can use to sort of overcome the challenges. Briefly, here's the tectonic setting. You have subduction of the Juan de Fuca plate interacting with rotating blocks that's causing shortening in the Puget Lowland. And this shortening is expressed as a series of north verging thrust faults separated by sedimentary basins. This is the Seattle fault zone. These are identified traces within the fault zone. This is a north verging thrust fault. It's displacing Eocene bedrock with quaternary sediments. This is showing different interpreted structures of the Seattle fault zone. The one in the upper right is in my study area of Bellevue, Washington. So just note the extreme change in depth to bedrock there as you move from south to north. So first what I did was look for lineaments in my study area, and I did this by looking at steep slopes that have an aspect, northerly aspect. And this was used as just a preliminary aid for identifying possible fault-related lineaments, and these dashed lines are those lineaments that I identified in the study area. So these were used as a basis for further investigating the borehole data through strip log sections. This is a depth to bedrock map from the 80s, and you can see it's based on just a few subsurface data points, and those are all water wells, and most of them don't reach bedrock. This is the data set that I used from the GeoMap Northwest project. It's a much higher data density in the study area of Bellevue here. So in RockWorks, this is a little detour from GIS, but RockWorks was used to organize this borehole data, build a model of the bedrock and the sediment, and then export that reorganized data set back into GIS. And this is what we have back in GIS. The red dots are borings or test pits that intercept the bedrock surface, and all the yellow points are those that don't reach the bedrock surface. So I'm going to show you now a couple of different interpolated rasters, and these are based on a couple important columns. One is top bedrock, which is the elevation of the top of the bedrock surface in all of the borings, and the other one was minimum depth to bedrock, which is calculated from the total depth of borings that don't reach bedrock. So this is the ordinary kriging model. This is only using borings that intercepted bedrock surface. So I identified in this image a couple of lineaments here that may indicate something about the structure of the Seattle fault zone. And toward the west, I think that the data is too sparse, and I don't think you really see anything significant there. This was the minimum depth to bedrock map. So this isn't showing you actual depth to bedrock in all areas of the map, but I think it's really interesting, and I think that there's more said in this image than in the other one. These are lineaments that I identified. So you have these lineaments which indicate, this one I think indicates the leading edge of the fault where you have bedrock starting to drop toward the north in the basin. I've compared the lineaments to lineaments identified in the LiDAR, and a lot of these line up, but there's no surface expression of this north trending lineament. We also did a comparison with seismic profiling. This is from 2008. This is the interpreted structure under Bellevue, and they've interpreted an uplift block here between the Vasa Park Trench and one of their section lines, which I think is this area here. So one of my big questions is, can we see clear evidence for an uplift block just looking at the borehole data in Bellevue. That's it.